Let us revise the definition of a function which you studied in 11th standard. A relation from A to B is said to be a function if every element of set A has only one image in set B. So every element of set A should have only one image in set B. If it is so, that relation becomes a function. This is the definition which we studied in 11th standard. That is, for every input, there will be a unique output. So I can say that relations and functions. So functions, they form a subset of relations. So all functions are relations, but all relations cannot become functions. And we studied about addition, subtraction, multiplication and division of two functions. Now, to check whether a relation is a function or not, we can do a vertical line check if the graph is given. For example, the graph is like this, say. This is the graph of the function. So we can draw a vertical line. Y-axis, origin, x-axis. I'm drawing a vertical line and checking. If it cuts anywhere, you can draw. If it cuts the graph at only one point, that means it is a function. It has a unique image, therefore it becomes a function. So to check whether a relation is a function or not, we can do vertical line check if the graph is given. If it intersects at more than one point, then it is not a function. For example, let us consider this parabola. I am drawing a vertical line and checking. It cuts the graph at 2 points. Therefore, it is not a function, but it is a relation. Now we are going to learn about types of functions. The first one which we are going to learn is 1-1 function. It is otherwise called injective function. Okay, the definition of injective function is the distinct elements will have distinct images. Distinct elements will have distinct images under that f function. Then it is called a 1-1 function. So to check whether it is a 1-1 function or not, we can do horizontal line check in case if the graph is given. For example, let us consider this is the graph of the function, say. So I am doing the horizontal line check. If it cuts the graph at more than one point, see 1, 2, 3 points it is cutting. Therefore, we can conclude that it is not a 1-1 function. To check whether it is a function or not, we do the vertical line check. To check whether it is a 1-1 function or not, we do the horizontal line check. For example, if you consider this parabola, let us draw the horizontal line. It cuts the parabola at 2 points. Therefore, it is not a 1-1 function. Now let us consider this. F of x is equal to x square. I am taking from n to n. So if I take 1, 2, 3, 4, 1 square is 1, 2 square is 4, 3 square is 9. So it is a 1-1 function. Whereas if I take from z to z, then it is not a 1-1 function, because 1 square is 1, minus 1 square is also 1, 2 square is 4, minus 2 square is also 4. It is a many one function. It is not a 1 function. To check if graph is given, we can do horizontal line check. If graph is not given, if the function is given as an expression, then how do we check whether it is a 1 function or not? We have a method. So we will consider f of x1 is equal to f of x2. And if you arrive at the result x1 is equal to x2, then we conclude that it is a 1 function. This is the method which we use to check whether a function is 1 or not. Or you may take f of x1 not equal to f of x2, and you have to arrive at a result that x1 not equal to x2. In that case also we can very well conclude that it is a 1 function. Then the next type of function is onto function, otherwise called surjective function. Okay, the definition of onto function is every element in the second set codomain should be the image of some element of the domain set X. So for every element in this codomain, there should be a pre-image in X. Then it is an onto function. So there should not be, I can say in other words, there should not be any element left over without a pre-image. Then it is not an onto function. Now, to check whether the given expression is an onto function or not, we take f of x is equal to y and we find x as a function of y, and we check whether for all values of y the pre-images can be calculated or not. That is, for all y belonging to the second set, we can have a pre-image or not, we have to check. So this is the method which we use to check whether the given function is onto or not. If a function is both 1 and onto, then we call that as a bijective function. It becomes a bijective function. 1 is otherwise known as injective, and onto function is otherwise known as surjective function. If a function is both injective as well as surjective, then it is called a bijective function. Let us start exercise 1.2. First question. Show that the function f from r asterisk to r asterisk defined by f of x is 1 by x is 1, 1 and onto, where r asterisk is the set of all non-zero real numbers. So you have all real numbers other than 0, because 1 by 0 is not defined, right? That's the reason. Now we have to check whether it is 1, 1 or not. So let us take f of x1 equal to f of x2. So f of x1 is 1 by x1 and f of x2 becomes 1 by x2. So cross multiply, we get x1 is equal to x2, and it is true for any two elements taken from the first set, the domain r star, r asterisk. Therefore, we conclude that f is a 1, 1 function. We have to check whether it is onto or not. Now let us take f of x as y. F of x is 1 by x. Therefore, x is equal to 1 by y. Now we will consider this as g of y. Y cannot be 0. Other than 0, for all values of y, there exists x in the domain such that, so you have to write that step. So for all y belonging to the second set, the codomain is also r star, there exists, this is the symbol for there exists, or we may write in words, there exists x which is equal to 1 by y belonging to the first set R star, and f of x is equal to, let us calculate, f of x is 1 by x, our x is 1 by y, which becomes y. Therefore, I can conclude that f is onto. Is the result true if the domain R star is replaced by n with codomain being the same? The first set is n. So let us check whether it is 1, 1 or not. So I will name this as function g. So let g of x1 is equal to g of x2. This is 1 by x1. The function is the same. So g of x is 1 by x. So 1 by x1 is equal to 1 by x2. If I cross multiply, I get x1 is equal to x2. And it is true for any two values taken from the domain n. Therefore, I can conclude that g is 1, 1. Now we have to check whether it is onto or not. Let g of x is equal to y, which is g of x is 1 by x. Therefore, x is equal to 1 by y. If y is 2, x is 1 by 2, and it doesn't belong to the first set. So I can say that the element 2 of the codomain doesn't have a pre-image, right? Therefore, one counter example is enough. Therefore, I can say that it is not an onto function. Now, second question. First subdivision. Check the injectivity and surjectivity of the following functions. The function f is from n to n. N stands for the natural number set given by f of x is equal to x square. Both are n, 1, 2, 3, 4, etc. So 1 square is 1, 2 square is 4, 3 square will be connected to 9, etc. So it is a 1, 1 function. So we have to write the proof. Let f of x1 is equal to f of x2. So x1 square is equal to x2 square. Taking square root. If I take square root, I should not write plus or minus sign here. So x1, x2 both belong to n. So I should not write plus or minus sign when I take the square root. And it is true for any two values taken from the domain. Therefore, I conclude that f is a 1, 1 function. Now let us check whether it is onto or not. Look at the arrow diagram. Arrow diagram is very easy to understand the function. Okay, so here 1, 4, 9, 16, etc. These are the perfect square numbers. Only those numbers are having pre-images. For example, 2 and 3, we don't have pre-images. So give one counter example, that is enough. 2 belonging to n doesn't have a pre-image. The pre-image will be square root of 2, which is not there in n, in the first set n. Therefore, f is not onto. Or you can write there is no element in the domain n such that x square is equal to 2. Therefore, f is not onto, we can conclude. Now the second subdivision. F is defined from z to z Z is set of all integers where f of x is x square. So set of all integers means we have 0, plus 1, minus 1, plus 2, minus 2, etc. So 0 square is 0, 1 square is 1, minus 1 square is also 1. 2 square is 4, minus 2 square is also 4. So definitely it is not a 1-1 function. If it is not a 1-1 function, you may give one counter example. See, you can say that f of 1 is equal to f of minus 1. Both are 1 square, that is 1. So it is a many 1 function. Therefore, f is not 1-1. So one counter example will do. Next, let us check whether it is onto or not. Square of a number. If you see, the answers are all perfect squares, positive numbers. See 4, 1, 9, 16. Because you are squaring. Therefore, the answers are all positive perfect square numbers. For negative numbers or for 2, you don't have pre-image. So you give one counter example. For example, let us take minus 1. Let us take y is equal to minus 1 belonging to z. There is no element in z such that x square is equal to minus 1. Therefore, f is not onto. Or you can simply say minus 1 doesn't have a pre-image, therefore it is not an onto function. Now the third subdivision, f is from R to R. Same function but the sets are different. And f of x is x square. So real number set to real number set. All possible numbers will be there. So definitely it is not a 1-1 function. I can give the same example. Or f of 2 is equal to f of minus 2 is equal to, both will become plus 4. So 2 and minus 2, both are having the same image 4. Therefore it is not a 1-1 function. Now let us check whether it is an onto function or not. Okay, the images are all positive numbers, I can say. So for negative values, you don't have pre-images. For example, let us take minus 1. Square of any number becomes positive. The answer cannot be negative. So we can say for y is equal to minus 1 belonging to the second set R doesn't have a pre-image. Therefore, f is not onto. Fourth subdivision, f is from natural number set to natural number set given by f of x is equal to x cube. So n to n. In n you have 1, 2, 3, 4, etc. 1 cube is 1, 2 cube is 8, 3 cube will be 27, etc. So it is a 1-1 function. So we are going to prove it. If it is true, we cannot use examples. We have to write the general proof. Let f of x1 is equal to f of x2. So x1 cube is equal to x2 cube. Now take cube root on both sides. When you take cube root, we don't put plus or minus sign. So we get x1 is equal to x2, and it is true for any two elements taken from the first set n. Therefore, we conclude that f is a 1-1 function. Now let us check whether it is onto or not. For these elements, we don't have pre-images. So any one counter example will do. So let us take y is equal to 2 from the second set. There is no x belonging to the first set such that x cube is equal to 2. Therefore, f is not onto. Now fifth subdivision. The function is defined from set of all integers to set of all integers, and f of x is defined as x cube. So set of all integers, we have positive as well as negative integers, 0 also. So 0 cube is 0, 1 cube is 1, minus 1 cube is minus 1, 2 cube is 8, minus 2 cube is minus 8, etc. Let f of x1 is equal to f of x2. We get x1 cube is equal to x2 cube. Taking cube root on both sides, we get x1 is equal to x2, and it is true for any two elements taken from the first set Z. Therefore, we conclude that f is a 1-1 function. Now on to see the answers. So they are perfect cube numbers. For example, if I take 2, there is no pre-image for that. So let us write y is equal to 2 belonging to the codomain Z. So there is no x belonging to Z such that x cube is equal to 2. Therefore, f is not on 2. Question 3. Prove that the greatest integer function f from R to R given by f of x is equal to the greatest integer function is neither 1-1 nor onto, where this denotes the greatest integer less than or equal to x. We did greatest integer function in 11th standard. Real number set to real number set. No need to draw the arrow diagram. I am explaining it so that it will be easy for you to understand. For 0, the answer is 0, we know. And for all real values between 0 and 1, excluding 1, for all real values including 0, that is 0, 1, we know that the greatest integer function becomes, so f of x in this interval becomes 0. So how many real values are there between 0 and 1? Infinitely many. For all these values, the answer is 0. Then from all real values 1 to 2, so many real values are there between 1 and 2 including 1. The answer, greatest integer function, becomes 1. For example, greatest integer function for 1.5 is 1. For 1.99 is also 1, etc. So it becomes a many 1 function. So you can write this reason. For all x belonging to 0 to 1, f of x, that is greatest integer function of x, takes the value 0. So many real numbers are there in this. Therefore, I can say that f is not 1-1. It is a many 1 function. Okay, let us check whether it is an onto function or not. I can say that the answer is always an integer because it is a greatest integer function. So the answer is going to be positive or negative, but the answer is going to be an integer. But this is a real number set. For example, if I take a value 1.5 here, 1.5 cannot be the answer for a greatest integer function, because if I take any value 1.55, let us take, the greatest integer function becomes an integer 1. So we cannot get the answer 1.5. So we can write that. So for y is equal to 1.5 belonging to R, there is no x belonging to R such that greatest integer function of x is equal to 1.5. Therefore, f is not onto. So to prove that it is not true, you may use a counterexample. If it is true, you have to write the general proof. Now question 4. Show that the modulus function f from R to R, f of x is equal to modulus of x, we have done this also in 11th standard, is neither 1, 1 nor onto. Now this is very easy. F of minus 1 as well as f of 1. This is modulus of minus 1, this is modulus of plus 1. Both the answers are same. So for minus 1 as well as plus 1, the answer is plus 1 only. So it is not a 1, 1 function. Therefore, f is not 1, 1. An onto function. For modulus of x, I know that the answer will be positive. So for negative values, we don't have pre-images. For example, let us take minus 1. The answer for this modulus function never takes a negative value. So give one counter example. For example, let us take y is equal to minus 1 belonging to the real number set codomain R. For y is equal to minus 1 belonging to R, there is no x belonging to R such that modulus of minus 1 or modulus of x becomes minus 1. Therefore, f is not onto. Then question 5. Show that the signum function from R to R given by f of x is equal to 1 when x is greater than 0 and 0 when x is equal to 0 and minus 1 when x is less than 0. Signum function can be defined like this also. Absolute value of x by x when x is not equal to 0 and 0 when x is equal to 0. This is from real number set to real number set. For all positive values, for all positive real numbers, the answer is 1. How many positive real values are there? Infinitely many. For all negative real values, the answer is minus 1. And for 0, it is 0. Definitely it is not a 1, 1 function. So we can say f of 2 and f of 3, both are positive values, so the answer is 1. Therefore, f is not 1, 1. Okay, now let us check whether it is onto or not. The range of this function is 1, 0, minus 1. Only 3 answers it can have. For other real values, for example, if I take 2 from the second set codomain, we don't have a pre-image. So y is equal to 2 belonging to the second set. For this element, there is no pre-image. X belonging to R. Therefore, F is not onto. Question 6. A be the set 1, 2, 3 and B is the set 4, 5, 6 and 7. F is defined as, it is given in roster form 1, 4, 2, 5, 3, 6. 3 elements it has. Be a function from A to B. Show that F is 1, 1. So F is a function from A to B. A has 3 elements, B has 4 elements. 1's image is 4, 2 is related to 5, 3 is related to 6. So show that F is 1, 1. Yeah, it is a 1, 1 function. If it is an expression, f of x is given as an expression, then we use that f of x1 is equal to f of x2 method. Here roster form is given, so we will write the definition. Distinct elements have distinct images. Distinct elements of A have distinct images in B under F. Therefore, F is a 1, 1 function. Very easy question. And if you notice, it is not an onto function because for 7 you don't have a pre-image. Therefore, it is not onto, but it is not asked in the question. Now, question 7. In each of the following cases, state whether the function is 1, 1 onto or bijective. Justify your answer. The first subdivision, f is from R to R, defined by f of x is equal to 3 minus 4x. So here the function is given as an expression. So we may use that f of x1 is equal to f of x2 method. So let us check whether it is 1, 1 or not. Let f of x1 is equal to f of x2. F of x1 is 3 minus 4x1 and f of x2 is 3 minus 4x2. I can cancel the negative 4 also. We get x1 is equal to x2. And it is true for any two elements taken from the first set R. Therefore, I conclude that f is 1, 1. Or you may write in words also. Distinct elements have distinct images, but if you are able to show that x1 is equal to x2 by taking f of x1 is equal to f of x2, we can directly write that it is a 1, 1 function. Then we have to check whether it is onto or not. So to do so, we take f of x is equal to y and f of x is 3 minus 4x. Now let us find x. So 4x is 3 minus y. Therefore, x is equal to 3 minus y divided by 4. Now check whether this 3 minus y by 4 can be calculated for every value of the codomain or not. Yeah. So for all values of y in R, we can find this quantity which is x. That means all y in the second set, they have the pre-images. So we will show that. Now let us calculate f of this. This is the answer, right? X. This is our x. So let us calculate. Substitute in f. F is 3 minus 4 times. My x now is 3 minus y by 4. So it becomes 3 minus of this, which is y. Therefore, we can conclude that f is onto. Therefore, for every y belonging to R, there exists an x in R. Therefore, R is onto. Now question 7, second subdivision. F is from R to R, defined by f of x is equal to 1 plus x square. This is not a 1-1 function because of square function and real number set to real number set. I am using a counter example. F of 1 is 1 plus 1 square 2. F of minus 1 also gives you the same answer because you have x square. So both 1 and minus 1, they have the same image too. So it is not a 1-1 function. Now let us check whether it is an onto function or not. So let us write f of x is equal to y, and f of x is 1 plus x square. So x square is y minus 1. X is root of y minus 1. We can have plus or minus sign also, but we cannot have negative values under square root. So y minus 1 should be strictly greater than or equal to 0. So y should be greater than or equal to 1. So only for the values greater than or equal to 1, we have pre-images. For other values, we don't have pre-images. For example, 0 let us take. If y is 0, 0 minus 1, root of 0 minus 1 is root of minus 1.
Which is a complex number, but the set given is a real number
So
set.
we cannot find the pre-image. So we will write one counter example. 0, y is equal to 0 belonging to the second set. For y equal to 0, there is no pre-image x belonging to R. Therefore, R is not onto. Question 8. Let A, B be two sets. Show that F from A cross B to B cross A and F of A comma B is equal to B comma A. This is the definition of the function f. Is a bijective function we have to prove. Okay, here this is A cross B set and this is B cross A set. So if you have AB element here, definitely BA will be here. And if you take C comma D here, D comma C will be here definitely because it is B cross A. Okay, we have to prove that it is a bijective function. Let us show that it is a 1-1 function. Let f of A1 B1 is equal to f of another element A2 B2 I am taking. So this is connected to B1 A1 and this will be connected to B2 A2. If two ordered pairs are equal, we know that their first element should be equal and their second elements should be equal. So B1 must be equal to B2 and A1 must be equal to A2. Therefore, we can say that A1 B1 is equal to A2 B2. And this is true for any two elements taken from the first set. A2 B2 belonging to the first set A cross B. Therefore, I can conclude that f is 1-1. Now we have to check whether it is onto or not. Let B comma A belongs to B cross A. So for any element B comma A belonging to B cross A, there exists A comma B belonging to A cross B. Definitely B comma A is in B cross A, A comma B will be in A cross B. Such that f of AB is equal to BA. Therefore, I can say that F is onto. Question 9. F is from n to n, defined by f of n is n plus 1 by 2 if n is odd, and n by 2 if n is even. N to n. One is an odd number, so I have to use this definition. 1 plus 1 by 2. 2 by 2 is 1. 1's image is 1. Then 3 is an odd number, so I have to use n plus 1 by 2 definition. 4 by 2. 4 by 2 is 2. Then 5 is an odd number. 5 plus 1 by 2. 6 by 2 is 3. Now 2 is an even number. For even numbers I have to use this definition, n by 2 definition. So 2 by 2 is 1. 4 is an even number, so n by 2 definition. 4 by 2 is 2. 6 is an even number. 6 by 2 is 3. Look at the figure. We can make out that this is not a 1-1 function. So you can give one counter example. So f of 1 and f of 1 is 1. F of 2 is also 1. Therefore, f is not 1-1.
Therefore, it is not a bijection. Now question number 10.
A is the set R minus 3 and B is R minus 1. F is a function from A to B defined as f of x is equal to x minus 2 divided by x minus 3. We have to check whether f is 1-1 and onto or not. So let us take f of x1 is equal to f of x2. x1 minus 2 divided by x1 minus 3 is equal to x2 minus 2 by x2 minus 3. Let us cross multiply. Open the brackets. Use distributive property. Cancel the terms and bring x1 terms on one side and x2 terms on the other side. We get minus x1 is equal to minus x2, x1 is equal to x2. And it is true for any two elements taken from the first set A. Therefore, we conclude that f is 1-1. Now we have to check whether it is onto or not. So for that we take f of x is equal to y and f of x is x minus 2 by x minus 3. Let us cross multiply. We have to find x. So let us bring x terms together and 2 minus 3y on the other side. Take x out and find x. After cross multiplication, remember to collect x terms on one side and find x. Okay, now check. This expression we cannot calculate only when y is 1. Right? But in B, look at the B. B is r minus 1. Y cannot take the value 1. 1 is not there in B. So we don't have any problem. So for all values in B, we will be able to find the pre-image. Therefore, for any y belonging to B, there exists x, which is 2 minus 3y by 1 minus y in A, such that f of x, which is f of 2 minus 3y by 1 minus y, let us substitute. X is 2 minus 3y by 1 minus y. Substitute here in the definition. Minus 2 divided by x. X is this. Minus 3. So take LCM. 2 minus 3y minus 2 plus 2y. Here also take LCM 1 minus y. 2 minus 3y minus 3 plus 3y. Let us simplify. We get minus y divided by minus 1, which gives us y. Therefore, I can conclude that f is onto. So it is a surjective function. Question 11. F is defined from real number set to real number set, and f of x is, the definition is x power 4. Okay, let us check whether it is a 1-1 function or not. Here f is not a 1-1 function. I can give one counter example. F of 1 is 1 power 4, 1. F of minus 1 is also 1, minus 1 power 4 is also 1. Therefore, I can say that f is not 1-1. Now this is R to R. For example, let us take minus 1. So 4th root of minus 1 is the pre-image. So we cannot calculate. We will give that counter example. Y is equal to minus 1 belonging to R doesn't have a pre-image x belonging to R such that x power 4 is minus 1. Not possible, right? 4th power cannot be a negative value. Therefore, we conclude that f is not onto. So it is not 1-1, not onto also. So D is the correct option. Question 12. F is from R to R and f of x is defined as 3x. Now let us check whether it is 1-1 or not. Let f of x1 is equal to f of x2. So 3 times x1 is equal to 3 times x2. We get x1 equals x2. And it is true for any two numbers taken from the first set R, the domain. Therefore, we conclude that f is 1-1. Now let us check whether it is onto or not. Let it is the real number set. So f of x is equal to y. And our f of x is 3x. Find x. So this y by 3 can be calculated for any y belonging to the second set. We don't have not defined case. If you take any real number, it can be divided by 3 and the answer is also a real number. So for any y belonging to R, there exists x belonging to R such that f of x is equal to f of y by 3. So use the definition 3 times y by 3. f3x is the definition, which is y. Therefore, we conclude that f is onto. So it is 1-1 as well as onto. A subdivision is the correct answer.